4.6 homework, the last homework with logs, much like the 4.5 homework. This one might take you a little while. There's only 13 problems on this one, so not as many as you saw in the last assignment. But I think what you'll see are several of these take you longer than the previous ones will. These first few shouldn't, though. Hopefully this will be pretty straightforward. I tried to demonstrate something similar in the basic equations video. I think because we only have one x in this equation, it's fairly straightforward how you can solve for it. Note that they can say that your answer can be an exact value, meaning an expression, or if it doesn't work out to simplify to a really nice number, you can just throw it into a calculator or something and round to 4 decimal places. My advice to you is try to leave them as exact values. Don't be afraid to answer expressions if you end up with expressions as your answer. I think everything you do in this chapter can be done without a calculator. Question 2 is kind of more the same. The difference between 1 and 2 is here they start you out with the log equation. Here they start you out with an exponential equation, so you'll have to introduce logs in order to solve it. And I think if you do this the way that most students do, you'll end up with like the natural log of something. And you're like, I don't know what number the natural log of some number is equal to. But don't worry about that. Again, you can leave your answer in terms of logarithms. Or if you really don't want to, you can put it into a calculator and write it correct to 4 decimal places. 3 is similar to 2 in that they start you out with an exponential equation, so you'll have to introduce logs. And I think much like 2, your answer might end up being an expression as opposed to some like whole number or fraction. 4, I guess, is more like 1 in that they start you with the logarithmic equation, except now instead of being the log base 2, so that there's a chance that all the numbers work out nicely, it's the natural log. So you're going to end up with an expression as your answer, like e raised up to some power minus something divided by something, that kind of idea. Question 5, now we're back to exponential equations, so you'll have to introduce logs to solve this. You can take the log with any base that you want, and you'll get the right answer. Maybe log base 4 will make things work out the nicest, but you could also use, I don't know, the natural log if that were easier to type your answer in, if you didn't want to have to specify the base and use ln instead. And then question 6, the last of the, basic, which doesn't necessarily mean easy, just means they start you out with a single variable. The letter x only shows up one time. To solve for x, we want to isolate the log base 3 of x, so maybe you could think of how to get rid of, informally speaking, this 13 and this 2. And then once the log base 3 of x is all by itself, you can figure out how to solve for x. Question 7, this is where we get into the more advanced types, I guess. Sometimes they're harder than the basic types, sometimes they're not. The key thing here is the letter x shows up multiple times. But hopefully I picked examples in the advanced video that give you the skills that you'll need to solve any of these guys. And this specific one, it's really tempting to do 10 to both sides of the equation right off the bat, and then just cancel out this log base 10, this log base 10, and this log base 10. Please don't do that. You cannot do 10 to multiple different terms. What you need to do is make this a single log on the right-hand side of the equation first. So maybe you can think about your first log rule before you try to get rid of the logs. Question 8, no logs, but since it's in this chapter, you're going to have to introduce them. It would be nice if this 100 weren't here. Maybe you divide both sides of the equation by 100 before you take any logs. And then you're like, all right, logs, log base 1.02, I guess. I mean, you could do that if you want, but I think what I would probably do, instead of having a decimal as the base in my log, is just take, I don't know, the log of both sides, or the natural log of both sides, whatever. It doesn't really matter what base you choose. 1.02 is a pretty strange base. No matter what you do, you're going to end up with an expression as your answer. So what I'm saying is I'd probably divide both sides by 100, then maybe take the natural log of both sides. But you have lots of different options. Question 9, again, we see these two different log terms. Eventually, you want to get rid of the log base 2 by doing 2 to both sides of the equation, but you can't do that immediately. However, maybe you could combine these two logs using your first log rule. I think this is very similar to the second example that I did in the advanced log equations video, in that I think you're going to end up having to solve a quadratic equation. When you do that, if you get 2 answers, make sure to check your answer. Any negative answers won't work because you can't take the log base 2 of a negative value of x. Same thing here. It'll work out slightly different because on the right-hand side, instead of having a number, you have a log, but combine the left-hand side into a single log and then get rid of all the logs on both sides, and then maybe you can solve the equation. And again, if you get 2 solutions, make sure to check those solutions because only positive values of x work. Negatives don't work, nor do zeros. You can't take the natural log of anything that is not positive. Getting close to the end here, now we have 2 different x's, but they're both up in the exponent. I made a video showing you how to do this. In the video, I think this was like an 8 and a 4. In this example, it's a 6 and a 2. When it was an 8 and a 4, I could get really clever and do the log base 2 of both sides, and things worked out really nicely. But with a 2 and a 6, I don't think it's going to work out really nicely no matter what base you choose. So you can choose any base you want. You can choose log base 2, and that'll make the right-hand side nice, but the left side ugly. You can choose log base 6, and the left will be nice, and the right will be ugly. Or if you want, you can just choose the natural log of both sides because it really doesn't matter. Either way, you're going to end up having to collect all the terms with x's on them on one side of the equation, and then maybe factor and solve for that remaining x. Question 12 is almost identical to question 11. The only difference is in 12, we have these coefficients as well. So the method used on 11, it'll almost be the same as the method used on 12, except now, if you take, I don't know, the natural log of both sides of the equation, you'll have the natural log of 6 times 1.12 to the x power. So you can't bring the x down in front. You have to first use your first log rule before you can use your third log rule. That'll happen on both sides of the equation. But after you use your first and then third log rules, you'll end up with something that's linear. You can collect all the terms with x's in them on one side of the equation, factor out an x and solve for it. You'll end up with a pretty ugly expression as your answer here, as you will here and on several of these questions. And then 13 is extra credit. I just thought it was kind of fun. Lots of different ways you can deal with it. The way I would think about it is, this is the log base 4 of something. And yeah, that something happens to be the log base 4 of x, but don't worry about that. The log base 4 of something equals -2. Is there something you can do to both sides of the equation to get rid of this log base 4? Yeah, we'll leave this one behind, but that's fine. Just try to get rid of this one. And if you can get rid of this one, then you'll be left with an equation that's just the log base 4 of x equals something. And I think that that's an equation that you can solve. This will be kind of a recursive idea. I think it's kind of interesting. If you get the hang of it, it'll be really easy for you. But if you don't see it, that's okay. It's an extra credit question, not something you need to be able to do for this class.